Hi you guys, today we're going to work out of our Big Ideas book. We're in chapter 5, section 4. We're taking a break away from the proofs today, and we're going to talk just about isosceles and equilateral triangles. If you guys remember, equilateral triangle, equal is equilateral sides. For equilateral triangle, all three sides are equal. Isosceles triangle, you have two or more sides equal, and we usually just say two sides are equal. Okay, that's your isosceles, that's your equilateral. We've got 1, 2, 3, 4 different things we're going to talk about. It's not too hard, really. It's kind of like just two things about one thing about isosceles and one thing about equilateral triangles, and then we get a few problems. Okay. It won't take too long. Today's pretty quick. It's more applying it and doing algebra. Okay, so when you have an equilateral triangle, you have two sides that are congruent. You could say the two lengths are equal, and those are called legs. So the legs are the two sides with equal length. Okay, the two sides that are equal length are called your legs. Now, where these two legs intersect, these two legs form this vertex angle. So up here, where the two legs intersect, right, up here, that is your vertex angle. If you remember, it's two rays with the same end point that make an angle. This is your vertex angle. Okay, formed by the two legs, okay? And the vertex is always where the two sides meet. Okay. So you've always got two legs, one leg, two leg. The other side is always called the base. So the base is that third side. Okay. And then we always talk about base angles. Okay. So the legs are in yellow, your base is orange. Okay, that's your base. Your third side is your base. And the angles formed with the leg and the base are called base angles. Okay? A leg and a base, a leg and a base. These are base angles. Vertex angle, the other two angles are base angles. 1, 2. Base angle, base angle. Okay? So you have one vertex angle, one base angle, then another base angle. 1, 2, 3 angles. Okay, the base angles are always adjacent to the base. I always say this too, I don't know. Base angles sit on the base. They're adjacent to the base. It's not the vertex angle, it's the other two. Okay, the sides formed by a leg and the base. Okay, so you need to know those words. Those terms will show up. Okay, base angle theorem. I'm not going to say what is the base angle theorem, but you do need to be able to apply it. It goes like this. If two sides of a triangle are congruent, which I have here, two sides are congruent, then the angles opposite the two sides are congruent. And I'll show you what I mean. If two sides of a triangle are congruent, then the angles opposite the two sides are congruent. And it's also, these are the base angles. Okay. So when you look at this picture, I want you to think about hinges. Okay. So this angle B is right here. Okay. It's not a great, these are kind of big, but you got the idea. This angle is on a hinge. Okay, so it opens, closes, opens, closes, opens, closes. When we talk about the opposite side of this angle, we're talking about the side that the angle opens up to. Okay? So when we're talking about opposites, we know this is a vertex angle, always, because that's where the two legs meet. These two angles down here are the base angles, and they are opposite of the legs. So if two sides are congruent, then these two angles are congruent. Let's write this way. That means if, let's say the two sides, we're saying this side A to B, start to end, right? Side AB is congruent to, and here's my other hash mark, which means this side, start to end, side A to C. So if A to B, that length, that segment is congruent to this segment, then the angles opposite are congruent. Because there's only one angle at this vertex, I could say angle B is congruent to angle C. Okay, if the sides are congruent, opposite angles are congruent. Now, converse is simply when I switch the hypothesis, the words after if, with the words after then. We're going to switch them. That is called a converse. Okay? Con is to switch. Con man, switching things, tricking. Okay? So I've got my if, my then. I'm going to switch, instead of if this, then this, I'm going to say if this, then this. Converse. If two angles of a triangle are congruent. So this time we're saying if the two angles are congruent. So if angle B is congruent to angle C, then, what do you guys think is true? If the angles are congruent, then, on this one we said if the sides are congruent, then the angles are congruent. This time we're just switching it. If the angles are congruent, then you fill it in. The sides opposite are congruent. The two sides opposite the angles are congruent. Okay? If angle B equals angle C, the side that it opens up to is congruent to the side that it opens up to. So we're going to say length AB is equal to length AC, or we could say segment AB is congruent to segment AC. Okay. On this one, last one, then it's just work. Okay, this is, if you remember, this is called an equilateral triangle. Okay, it's also called equiangular. So if a triangle is equilateral, then it's equiangular. If all three sides are equal, then all three angles are equal. They have equal measure. We're going to do the converse of that. If all three angles are equal, that's your if, then all three sides equal. So if the three angles, so we're just switching this. Instead of if equilateral, then equal angular, we're saying if equal angular, then the triangle is equilateral. Okay? That's all we did was switch it. We switched the hypothesis and the conclusion. Okay. I'll talk through a couple of these problems, just a few. We got if side HG is congruent to side HK, so H to G is congruent to H to K. Okay, so ignore what's over here. We're not even looking at it, right? We're just looking at this triangle. If these two sides are my legs and they're congruent, then what angles are congruent? You guys fill it in? If the sides are congruent, then the base angles are congruent. Okay? And then we're looking at this one is totally different. It's a new one. Different problem, right? We're just starting a new problem. If angle KHJ, you walk it and talk it, K to H to J, the middle letter is always the vertex, K to H to J. So if this angle, we're going KHJ, is congruent to KJH, so we walk this one, and it's this angle. Okay, so this time we're not looking at, oops, let me move it, I'm sorry. Okay, this time we're saying this angle is congruent to this angle. So what do we know is true? I'm going to redraw it over here. These are my two base angles, so what would be my legs? If I turn my paper and look at it this way, sometimes it's easier. If these are my base angles, then my sides that are congruent would be this one and this one. If the base angles are congruent, then the legs are congruent. Move that back around. Some of you guys don't need to do that. Okay, again, I'm looking at just this triangle right here. Okay, and this time I'm saying this angle is congruent to this angle. So what would be my two sides? My two legs would be this side and this side. From H to K, and from J to K. Those are my legs, these two here. So then, if the angles are congruent, then the sides are congruent. Side HK is congruent to side KJ. Okay, flip it over. It says find the measure of each angle. It says all the sides are equal, length, right? So this length equals this length equals this length. If it's, which means it's equilateral. Three sides are equal, equilateral. I'm just writing everything down. So if that's true, then three angles are equal, which means it's equal angular. If equilateral, then equal angular. So if these angles are equal, right, all three angles are equal, I know my golden rule of a triangle, the sum of the measures of the interior angles is always 180. So I've got all the angles together, and some of you may not need to write all this out. I am. So that means I have three angles that are same. So 180 divided by 3. So that means each angle is 60 degrees. If it's equilateral, it's equal angular, and each angle opens up 60 degrees. Each angle is 60 degrees. Okay? Measure of each angle is 60 degrees. Okay? Now this one here, it's not hard, but they're marking these two sides are my sides that are congruent. If these are the two sides congruent, what are the legs and the base? So that means this side is a leg, this side is a leg, because that's what's marked congruent. The third side is what we call the base. If I were to turn my picture, right, and make it look like, whoa, something easier for me to see, leg, leg, base. And these would be my base angles that are congruent. The base angles are always adjacent. They sit on the base. Up here, this would be my vertex angle. Okay? Leg, leg, vertex angle, base, and base angle, base angle. Okay. Now these questions, it says these are my legs. So that means if I look at this then, just like we did a second ago, just like that other problem, okay? If these are my legs, that means this has to be my base, and the angles on the base are always congruent. So if this one's 75, x is 75. That's all I gotta do. Find x. Okay? I want to do one that's not, I want to look at number 3. Okay, here's number 3. I'm turning my paper upside down. Okay, on this one, here's my triangle. This is my leg. This is my leg. This is my base. Okay? This is my vertex angle here. Okay, the legs intersect at the vertex angle. The base angles are always congruent. The angles opposite the legs, opposite the legs. So this angle here is congruent to this angle. This one's a little trickier. So if this one's 39 and these are congruent, that one's 39. Then you gotta go, okay, if this one's 39, 39 plus x, golden rule of 180. So this one's different from the one we just did, number 1. So when you're doing these problems, you got to pay attention which is the base angle, which is the vertex angle. So if this one's 39, your other base angle is 39. This one's x, so you're going to go 39 plus x equals 180, and then go ahead and solve that. And that'll tell you how much your vertex angle is. Okay? Okay. When you look at, okay, 1, 2, 3, 4, these are the same. Okay, oops. This one, you're going measure of angle 2 equals x plus 87. Okay? So on this one, this is a leg, this is a leg. Leg, 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 leg. Okay. So this side down here has to be the base, and then these are my base angles, the angles that are opposite the legs, the base angles. And we know if the sides, the legs are congruent, the base angles are congruent. So if this one's 51, this angle is 51. So I'm going to go 51 plus this angle here has to equal 180. Okay, try those, see what you can do. That'll get you through first 12. This one's the same idea. You got legs equal, base angles equal. This one's a little harder. Okay? You're going to pay attention. Look at this triangle first. Oops. This triangle here. Equilateral triangle. So how much is each angle? Once you know this angle, you know this whole angle is 90. So these are going to end up being 60. X plus x plus x. Equilateral triangle is equal angular, so they're all 60. This whole thing's 90. This part is 60. So this part's 30. So you just gotta do some work on these. I'll help you, but try and see what you got. Okay, good luck, you guys. You did well. Thank you.